going to talk about 212 word search second version. The question is given an m times n board of characters and a list of string words. Return all words on the board. Each word must be constructed from letters of sequentially adjacent cells, where the adjacent cells are horizontally or vertically neighboring. The same letter cells may not be used more than once in a word. The letter, okay, so which means if the word OATH, I cannot go back. Every word is just only used one time. Okay, so for these problems, it's used like you definitely use the DFS, like backtracking, right? We can start from this word, we can look like a tree, go this way. So for example, if we looking at K here, it has like 4 directions. So it's more like islands. I think that the problem number is little about 200. So we have the 4 directions to do the DFS, and also we need a visit to check whether we current words visit before. If not, we can go. If visit before, we cannot go back. So this is kind of like basic solution. For the data structure, we can use try to do this thing to start the dictionary. So which means it's kind of like we just need to looking for one time. Yeah, just use the try direction to work on this. So let's write the code. We need class is try node. The try node has its children. Because the character just only have 26, so I need to create this. Now also Boolean is a word. To check, because we store this one, so if we find the last one, we should make sure H1 to tell me, oh, current word is a word. So originally, initially it should be false. Okay, so we need another is try. Try is a node. New try node. Okay, so when it's finished, we can use the this function. Also need called insert. Insert is a string. Cur is equal to the root. To char array to translate the string into the word. Okay, so try node. Cur children C minus A, whether it's 6, right? So if the node not is equal to none, what's going to happen? This means node not equal to none, what's going to happen? So if the node is equal to none, we should create a node. So node should be the new try node. And cur children C minus A is none, right? We should equal to the node. And also cur should move to the nest. Okay, so if the null is not equal to none, so cur directly move to the nest. And when the word is finished, we need to change, which means the last character. Like for example here, so we need to change its word equal to true. Let's see. Okay, we can write here now. So for the string, we can create the result first. And create the dictionary. And also we need to create the try first. This one is finished. Now we can use like backtracking to do something. I would say that DFS, but backtracking is kind of one of the DFS. So we start from for the backtracking, right? So we start from here, 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 here. So we need just like a for loop. So we need then we should put the backtracking inside this way. We need int I, int j to start. Word, words, try node, readout, and I also need a string builder, kind of like subreadouts. And also to check whether visit before visited. I think everything is fine now. Okay, so we can write the backtracking. I'll return the result here. Yeah, this is the high level about this logic. Now we write more detail about backtracking. towards try node. And boolean visit. So we can check if some base case, if this out of boundary, right? So we directly return, or even t now coming t current here, right? So coming from this way, we cannot go back. So which means A is already visited before. So we can check in this base case. Current is visit. If not visit, so we come in for t, right? Char is equal to the board ij for here. So we need to check whether in the try node, cur children minus a equal to none is not exist, so we can return directly. And if current now is means the exist. So we should add in the current here, we should stream builder should add it, and visit should add it, and go into the next level. Equal to nest. And also we should add the and cur and visited is ij is equal to true. Now DFS for the different here. There are 4 directions, +1, +1 here, -1, okay. Okay, so this one is here. Now we update words, didn't change. This one should be changed, go into the next one. Okay. So this one, when we return back, okay, so we didn't use the words, so why we need this one? Yeah, delete. Okay. But for here, we need to remove the last one, because we will go to current here, right? Going to here, we need to go to the return back for this one to the different directions. Just for this way is already visit, but if we want to go this way, right? So we need to return back for the not impact other, because if you go see here, current enough, for example, if the current curve is h, right? This can go to the different direction, but when we go back for this one, and it will go to a, and a maybe can come here, right? So this one should be update the original one. Let's see. Oops. Okay, static. Where this one? Oh, if the children. Oh, not cur is the note. Delete. Not remove. Delete chart. Okay, this one works fine, but for this one, oh, we didn't put in the without. Next is word, then we can true, then we without add to string, and for the first, yep, can check. Yeah, we cannot return from here because even current here, like Apple, right? App area Apple and Apple Watch, it can be stopped at Apple here and also can stop at the watch. So we cannot return directly from this one. And for the time complexity is TC is O. We have 4 branch, right? So we have 4 branch, and suppose the most the word, the longest is this one. And also n times m plus, it should be like this. The worst will be this. And for the space is O1, but it's much smaller than this because it's backtracking. We have a lot of return. So improve. Yeah, for this almost the same. This O1, yeah. And thank you.